Hello, everybody. Welcome back to Electric Vision Entertainment. This is a weekly show that I'm hosting here on the Mixed Schools channel. We talk about robots, we talk about space, we talk about time, we talk about coding, anything tech related, motivational, philosophical. We got it all here. So, if this is your first time here, I'm Aleia. I'm going to be your host for today. Just a little about me. I am a computer science student at Mixed School studying data science and machine learning. As well as I do, my own thing, building robots, writing code, just trying to create new things to help build the future. If you've been here before, welcome back. Anyone can follow me on Instagram, is instagram.com. And my tag is Robot Gal. So you can follow me there to get more updates about when we're going live, the type of shows that we're going to do, as well as other tech things that are going on either in my life or in the world of STEM as a whole. So today, what we're going to do is we're going to try something a little different. Reason being, usually we'll get on here and we'll mostly have been focusing towards coding, but at Make School we have this thing that we do every term. It's called intensive, and that's because it's very intense. What we do is for a week, we start and come up with an idea, just like off top of our head, come up with that idea. And by the end of the week, we need to have coded it into reality. And so it can be a bit tough to go from this thing that you just thought of on the top of your head all the way to a finished product that's live or people can use. So with all of that coding for all day, every day for a week straight, I figure, let's wind it down a bit. Let's not do as much live coding this time, but instead we're gonna do what I would say is more of a thought explosion. I'm going to kind of give some of my perspective and mindset on time and space. And to assist with that, I'm also going to share some links that I'm going to be showing illustrations from. The thing I really like about these links is a coder made them, as you would think, it's on the internet, but it's a good way to see how code can be used for not just programming robots or making websites and doing crazy hard server things. Instead, it can be used as an educational tool and to make some really cool stuff on the front end as well. So for one, if you want to learn more about the intensive at Make School, definitely go to our website at makeschool.com, and there's plenty of information there. But for now, what we're going to do is I'm going to go ahead and share my screen, and we're going to get started a bit. I'm going to talk a little bit more about the site itself and the creator of the site. And then we'll get into time first, which I'm not sure which is more complex at this point, time or space, after talking to others about this. But we're going to probably start with time. So before we do that, this is a website called Neil.fun. It's created by this guy here, Neil, and he's just a coder, but he makes really cool things. So you can follow him on Twitter, or you can go to his site at neil.fun, which is how I came across his work. So there's plenty of little interactive things here that we can look at, but we're going to look at two in particular. One is the size of space, and one is the universe forecast. So that's kind of what we're going to do to go over the different concepts of time and space today. So we'll start with the universe forecast. We'll go through it and just kind of talk through a little bit of it. So prepare to have your mind blown. And then when we get more towards the end of it, I'll kind of give my own personal thoughts on what time is, how we interact with time. As I always tell people, time is a perception. It is a thing that exists. It's existed since existence was there. And it will continue to exist until time and existence is not there. We cannot fathom that concept because we are human. We are when you're within a system, it's just like a physics thing, but when you're within a system, it's hard to understand what happens outside of that system. If you're in a room, you don't know what's happening outside of the room. And so for us as creatures who are bound by time, who exist within time, it's hard for us to understand how big, how complex, and overarchingly eternal it is, which is why so many people get caught up in the idea of what is immortality and eternity and all of these crazy things. So we created a system of time for ourselves to be able to understand, which, months, years, decades, it makes sense to us. So, but when you really think about what it actually is and how big it is, that's when like your brain explodes. So this is what we're gonna do. We're gonna go into how long time is, have a quick brain explosion, and then we'll talk a little bit more about how we as people perceive time versus how time actually is, and how to kind of stay grounded despite the size of time. So this is the universe forecast. We're just going to go through it. So that's what is the future of our universe. Science, we can make a lot of predictions now. We have the technology. So we can use that technology and the things that we've observed about velocity, speed, distance, to make a lot of these calculations. So 2061, Halley's Comet will return again. Not too bad. Well, should be within our lifetime. So that's a realistic. Then 150 years from now, in 2078, Pluto will complete its first orbit since it's discovered. Now, mind you, we all have probably this interesting relationship with Pluto. I know I was heartbroken when they said Pluto was no longer a planet. It broke my soul. But ever since it's discovered, it's just then we'll have made one full rotation. So that kind of gives you a bit of the scale of things, to think that over 200 years later, it's just now getting around the sun. Or for us, it's a day to get all the way around, or a year. So in 2300, after traveling billions of kilometers, Voyager 1 will reach the Oort cloud. So not too much context there. We just keep going. But we can make a giant time leap. We go from 280 years later, approximately, to 50,000 years in the future. The star will explode into a supernova. So we're thinking large scale at this point, 50,000 years in the future, nothing too bad. Anyone who's watched anything sci-fi related, or like time travel, which I'm not a time travel person myself, but that's a topic for another day, why I'm not into time travel. So this will outshine the rest of the Milky Way. Pretty cool. 75,000 years from now, a new Hawaiian island will surface. Now imagine, like, we all know the idea of Pangea, but it's not usually something we experience in our life because it's such a slow moving thing that, hundreds of thousands, millions of years ago, these formations of the earth were in different locations. And now, within the past even few thousands of years, they haven't moved too much. These things, once again, take time. So to think 75,000 years for a whole new island to come up, it starts giving you a sense of like how slowly time can move, or how slowly things will change in time. As I tell people, and it is a common saying, the only true constant in life is change. It kind of is paradoxical because it is a paradox, but regardless of what happens, the thing you can be sure of is that things will change, whether it's where you are physically, where you are mentally, your skills, your talents, your relationships, how you interact with things in the world. Everything changes in time because time will perpetually move, and therefore you shall as well. So in 100,000 years, a lot of the constellations will be unrecognizable. For me, that is a very big thing. I love space. I love looking at the stars. It is probably the first thing I do when I go outside at night is look straight up at the sky, and I point out like Orion, the Big Dipper, the Little Dipper, and a couple other constellations as soon as I go out there. So I can only imagine what that would do to the research we have now. I mean, of course, this is way in the future. We would be super advanced by this point, so it may not change anything. But if we were 100,000 years in the future and we look back at like the books that we came out with now about these constellations, like they would seem so archaic because we probably as a race, as a species, would have evolved, but also space literally would have changed. It's not something we can control, and that's really the power of time is you exist in it, but there's no you can't have any control over it. So it becomes this really powerful, um, all-inspiring thing because you can observe it, but you can't do anything about it, and so it gives you this sense of acceptance. And I think that's why a lot of people, including myself, really like the ideas of time and space, is because you can interact with them, you can learn from them, you can make conclusions from them and draw other things from them, but there's ultimately nothing you can do to change what they are. So next we have a million years from now. You know, one with six zeros, very, very long time, very long time. Two of Uranus moons will collide. Can't catch a break. I can't even imagine what it would be like to watch two planets crash into each other, or two moons crash into each other. I actually don't want to imagine it, so it'll probably be like pretty crazy. But they're pretty far from us, which is something we'll explore soon. So in 50 million years, now we're getting into the crazy numbers that are they're going to become really hard to conceive pretty soon. But it does give you this sense of these things, while may or may not happen to the exact same degree that is written, you know, in this format, in this template, these events more or less will happen over time. And regardless of what happens to us, to the universe as a whole, these things will probably still happen. And so I think that's the power of technology is we're able to almost, you know, as that first image when I pulled the site up, that fortune, that crystal ball is with technology, we're almost able to create um, our own crystal ball where we can see 50 million years into the future, into places that we haven't reached, and who knows if we'll ever reach as a species. So it's a really powerful thing. I think technology, and especially being able to use like machine learning. And, I think that's why research and development is so important because you're able to look at these type of things and draw conclusions and make adjustments for the future based off of this. So 50 million years from now, the Martian moon Phobos will slowly break up. So Mars will get its own ring. I think that's pretty cool, frankly. Imagine if Earth had its own ring. Like, I mean, I guess we kind of do now because of all the things we've put into space, but to naturally create a ring would be really cool. So in 100 million years, as it gets this ring, Saturn will slowly lose its rings. Um, it's just a phase. 180 million years later, the moon continues to gradually slow down the Earth. Days become 25 hours long. As I'm sure many who are probably here as well say, you know, we wish we had more hours in the day. And there's positives and negatives to that, as well as different ways in which that could possibly come about. If you look at science, in this case, it's literally a matter of time. Whereas other ways, you know, finding ways to slow down time or our perception of it, um, we'll get into that. I'm gonna hold off on going into how we as humans digest time. So 60 million years later, total solar eclipse happens. Um, and then that'll be the last one because it's so far away that there will be none left. It won't be able to reach the sun's rays, won't be able to reach the moon, so we won't be able to see anymore after 600 million years. So hopefully you caught the one that we had a little while ago in case you don't want to miss it. 800 million years later, As the sun gets brighter, photosynthesis can't happen on Earth anymore. It's too much sun. If you've lived in Arizona, as I do, you will understand this concept very easily. It's so hot, so sunny that everything just dry all the time. It's very hard to grow things when the sun is just bearing down. But on the upside, you're never cold. Um, so without plant life, animals go extinct. Therefore, humans go extinct, and thus the single cell organisms dominate the Earth again. We have regressed back to the beginning. In 1.1 billion years, billion, so we double time. Well, we've added a lot of time later. The sun will be 10% brighter. Doesn't sound like a lot, but this is the sun. Like, it would vaporize us if it were to get 10% brighter right now. So luckily for us, this is 1.1 billion years in the future. There is technology in the works now to extend human life. Different conversation once again. But I personally don't quite see us extending us to 1 billion years. So hopefully we don't have to worry about this. Temperature on Earth on average will be 116 Fahrenheit. Like I said, typical Arizona day. The oceans will evaporate, but Mars will become habitable. And so we can possibly move there. So things like this, once again, seeing that there's potential for life in the future, even if in this case there are 1 billion years from now, knowing that in time a planet like Mars, which is just a floating rock of red sand for the most part, eventually in time can become habitable. It gives hope for companies like SpaceX and NASA who are reaching to go to Mars. It does give them that hope that things can be turned around. If the planet can do it naturally, then it kind of gives these technology companies the idea that we can also create it. There's so many things we have in life now that were once natural and now we have created ourselves. Potentially the hubris of man, but it does give that idea that if we were to go to another planet, there is hope for that planet to be able to sustain life in the future. So in 5 billion years, the Andromeda Galaxy, which is the closest galaxy to ours, we're in the Milky Way. Very large, very large, very large. We're getting to the scale of that soon. So Andromeda, which is close galaxy to us, will collide with the Milky Way, which is where we are. So two giant galaxies crashing into each other. I could only imagine, literally only can imagine. So our next one we call Milkdromeda. I don't know if that's accurate or if they made that up as a pun, but actually I would enjoy that name. And we will gain 1 trillion stars. Anyone who manages to survive will have an amazing night sky. So by then, hopefully, humans have evolved into these eternal creatures that can live for billions of years and withstand extreme cosmic heat and potentially loss of gravity in air. 7 billion years, the sun becomes a red giant, gets 256 times larger than it is. 256 times larger. It is crazy. And then after all of that time, because it's so large, its density also increases. Therefore, its gravitational field will also increase, and it will suck up the Earth. Yes. And any little heart. Yes, so I want to also thank everyone who is on this. I want to take a quick moment to do a shout out to new subscriber, Lineheart, I believe. Probably pronouncing that wrong. But I want to thank you for following us and subscribing to our channel. We're here to blow your mind and to potentially make you think about things you haven't thought about before. So, welcome to the show. Buckle in. It is a crazy wide. Yes. So, yeah, so we're here in 450 billion years in the future. And at this point, more than 50 galaxies merge in our local group. Now, our local group is large. Think about this. Think of where we are on Earth, where you are, Arizona, California, Japan, Italy, Canada, all sorts of places. Take a moment to just think about, even where you are, where you've been in life, physically or mentally, right? And just keep scaling that up to a point where you can think of the idea of how big our galaxy is. I'm sure we've all seen Guardians of the Galaxy, things like that. They more or less stay within a local group of galaxies. Imagine that even larger. Like, when was the first time you really realized like where you were in the universe? Because I know for me, this was something that happened maybe around middle school, where was it middle school? Probably around middle school. So that's really when I got super into science. And I watched a presentation by my science teacher at the time, Miss Anderson. Shout out to you for inspiring my love of science. And we watched a video similar to the one that I'm going to be pulling up in just a moment. And it showed, us on Earth, and it just zoomed out of where we were, just kept zooming out. And at that moment, I realized like where I was in the universe, my place in the universe like made sense. So I challenge you to think about like when was the first time you really like realized like that you exist as a person in your state, in your city, in your household, but that you also exist as a person in our galaxy. It's quite a deep thought to think about. So at this point, we have 50 plus galaxies merging into each other. What would happen? Craziness. Trillion years. All the radiation from the Big Bang becomes undetectable. So at that point, we can't really see what's happening in the past about the creation of the universe because the footprints, just like we walk through sand, leave footprints, that radiation from the Big Bang is the universe's footprints. Once it becomes undetectable, we have really nothing from our current ideas of science and technology. We have nothing to trace back to the beginning of the universe. 10 trillion years, red dwarf stars turn into blue dwarf stars. Something that, who knows, maybe we create the technology to not only mathematically predict the future, but somehow visualize it, like make a telescope that can see into the future. That would be great. 100 trillion years from now, all the gas clouds needed to make stars are gone. The last star is born, and only neutron stars are left. Now, I want you to take a moment and look at the difference in time here. We go from 100 trillion years, which, mind you, is pretty hard to comprehend as a human ourselves because we live for, let's say 100 years on average-ish. 100 years. So, even in science fiction, you think of beings that are immortal, who live forever, who have just extremely long time frames. 100 trillion is just such a large number. There's not many things on Earth that you can really quantify in the trillions. There may be like one or two people who are about almost trillionaires. I don't even think there's that many grains of sand in the Earth. So these things are not something. It's easy for us to comprehend because we have no point of reference. I can understand 100 because I've interacted with something 100 times. I've held something 100 times, or 100 of something. But 100 trillion, it's not something to really do. So then we go to 10 to the power 15. Escalated very quickly escalated. Everything outside of our local group is impossible to reach due to expansion of the universe. Even the speed of light won't be fast enough to reach these galaxies. So quick point about that, and the speed of light and the expansion of the universe. There comes a point, which I guess in this case would be 10 to the 15th times years. There comes a point where, regardless, unless humans become so technologically advanced that we can find another unit of measurement that is larger than the speed of light or faster than the speed of light. I have no idea what that would be, but maybe the speed of time. I don't know. But if we go at the speed of light, the universe accelerates when it expands. So it's not going at the same rate of speed. It's not like you're riding in your car at 40 miles an hour. You're riding in your car and it just keeps getting faster and faster and faster. And so if it's getting faster and faster and faster away from us, then if we can only go at a maximum speed, there's no way we can catch up to it. So it's just going to keep going faster than we're ever going to be able to reach. So in this example, even if we were managed to go at light years at a time, the universe will be going faster than light years at a time. And so there may be things like way on the edge of the universe and these galaxies that we may never be able to see because they just are moving too fast for us to ever catch up to. Once again, I'm hopeful for our future, to where we can get to a point. Who knows? We may even be able to teleport one day. So this is wishful thinking, but these are things that like really inspire the mind to think outside the box for. These are really cool things that we want to happen in our future. Our future, we live in the future. When you look back at sci-fi from 10, 20, 30 years ago, the technology we have now is so beyond what they even imagined as like this crazy thing that could never happen in the future. So I can only imagine if now we're here in our present day and age to look forward and say these are things that like I can't comprehend as being real. Just because you can't comprehend it as being real doesn't mean it's not. It's the difference between perception and reality. So 10 to the power 17 years, white dwarf stars cool off, the universe goes dark. Only natural light comes from occasional supernovas, and 10 to the 30, black holes are all that's left. And we get some radiation. In the last seconds of a black hole's life, we get some light. There's some pictures out there. I don't think I have one to pull up really quick and easy. But if you look up pictures of black holes, I highly suggest it. They look really cool. Like, there's this, I guess it technically is a void, but when you look at it, you can see how there's actual space around it. And on the edges of the black hole, you can see the stars like actually blending in. It's not an illusion, it's not a Photoshop effect. It is actually what it looks like when a star's been sucked in, and then inside of the black hole is just nothingness. It looks like someone just got an eraser and got rid of things, but that's how they work. And so there's pictures out there of a few of them collapsing, and they have a really cool light ring around them. So it's just this black hole with a ring of light. Doesn't get much more sci-fi than that. But that's the cool thing about sci-fi, space-time, is it actually is based, sci-fi is really based on reality. It's just crossing that barrier into how cool can reality actually be. So providing the last light in the universe, like a final fireworks show, but each firework billions of years apart. After the universe is basically dead, nothing interesting happens. But don't worry, there's plenty of time left. In the life of the universe was a year. You're living in the first millisecond of January 1st. So enjoy the ride. So I think that's the end of this one. While we're here on this Ferris wheel, I want to give a point about this. That was my perception of this concept is, and feel free, of course, like in the comments, whether you're watching YouTube, whether you're watching on Twitch, feel free to hit me with some questions. If you're like wondering about like, how do we exist in time? So we're living in the first millisecond of January 1st of this whole presentation. So literally there's plenty and plenty of time left. Imagine if your entire life you've only lived and it was one day and you knew that you had to go through a whole year. Your perception of how things would work and how you would go about your life would be a little bit differently, or a lot differently, I would think, to know how much time you have. I think things like this, understanding the concepts of time, really can help you go about your life, because I think so many of us now rush, and it's a societal thing. You know, the times we live in, the days we live in, there is a lot of pressure to rush through life, to go quickly. But when you look at time and how big it is, and what time you have versus the time of the universe, I think it helps you to slow down, because it gives you this sense of, I want to make the most of what I have now. Because while the universe may go on for 10 to the 30th power years, I may not. And yes, you want to move forward in life, you want to do these things, but once again, the only thing constant in time is change. As long as you're focusing on what you want to do, and you're moving into things that keep you happy, keep you healthy, keep you feeling progressive and alert, then time will slowly push you towards that direction. But rushing it doesn't mean that it's guaranteed to go any faster automatically. Um, so I say, think of this as a way to kind of scale your life down. And we'll get into scale, like I said, once again, when we get into space scale. But think of this as a way, looking at time and how large it is, to tell yourself it's okay to move a little slower, because the universe is still going to expand, things are still going to move forward, and that's perfectly fine. So now, well, we've talked about time, and this all blends in. You know, if you can't talk about space without time, you can't talk about time without space. They kind of coexist. It's kind of how reality works in our general sense of what reality is. Can't too much have time without space. Um, do I think aliens are real? Yes, and I'll tell you why. I'm gonna get into that a little bit when we talk about the scale of space. But to give a brief overview of my idea of aliens, I don't think they look like TV aliens. They are not these green, 12-foot tall, giant headed creatures that we have been conditioned to see them as, which I do enjoy more about more common sci fi. Is, you know, they could be rocks, they could be microorganisms, they could be little dog creatures, it could be literally anything. Um, so, the reason I believe in aliens is, when I look at how big everything is in the universe, statistically speaking, how can there not be? Now, mind you, it does kind of depend on what you define life as. If you count a single cell organism as life, then most definitely, I would say. If you want to consider a full functioning brain, heart, body as an alien or as a life form, then it may be a little bit more. But you have to think of how many, we've already found one to two at least other Earth like planets. So, by our definition of life, there is a possibility of there being at least single cell organisms on that planet. We haven't been there. We don't know how evolved they are. They may have fully evolved into actual mammals or something else. They may still be single cell organisms. But that is by our definition of life. Who's to say that there's a planet um, 10 light years away from here, and there are creatures there? They may not have heartbeats, they may not have brains functioning in the same way that we do, but that doesn't mean they don't exist. You know, they still move, they still function, they still work in their own type of way. So when I think of all the stars that are out there, all the planets and galaxies, and how much time has passed since the creation of the universe, I just don't see it as, I can't see how we can only be we could be the only things living on in this universe or in our galaxy. Um, have the first people to live on Mars been born yet? Yes, I'm gonna say yes, because we are currently working on missions now to go to Mars. Mind you, the trip to Mars is about 3 months. So say we send someone now, they'll get there in 3 months, and then they decide to not come back, which really isn't something that's probably going to happen right now. But if they were to, then technically, yes, they've already been born. But let's push it out, say 10 years from now. Um, we have more advanced technology. I know NASA right now is working on the mission. Artemis mission is for the purpose of getting us to Mars. So we get to that point, we're able to take more water with us. We're able to build habitable stations, grow things there. I think it's very possible for people to live on Mars within our time span. So I would say yes. Even the people who, let's say, born today, they have, say, 100-ish years from when they're born to die. That's plenty of time for technology to change. You think of how far technology and space travel has come in the past couple decades, and how exponentially fast technology has been evolving since. It only makes sense that people will be living on Mars that are currently alive right now. Um, I'll answer one more question before I get going into the next part. Is the best way to get water in space? So that's a great question. Um, I was speaking to some scientists at NASA. I know someone who is working on that mission, and they're explaining some of what they're doing now. So the Artemis mission, like I said, is to get us to Mars and to make it so we can live on Mars. The big problem, one of the big problems with that, is water, because it's heavy. And so it takes a lot more money, it takes a lot more fuel and energy to get it off Earth. Not only that, but then we're taking water from Earth that we need on Earth. So it becomes a problem. So what the plan is we'll create like a orbiting station around the moon for rockets to go there, redock, refuel, etc. The main part of this mission, before they can do anything else, is they're looking for water on the moon and on Mars. If it's already on Mars, don't have to worry about it. And I think they said they're finding like frozen lakes on Mars, like way down deep. Similar with the moon, there are places on the moon where there is water. It's just frozen. So rather than taking all of our water from here, is they're trying to, for one, be able to get water from the planets that we're going to already, but also, utilize different technologies so that we can create water. It's a bit harder, to say the least, to create water. But right now, like I said, the current method is to just take it with us. But it's definitely not a sustainable option, and it's a very costly option. And to think of how much water you would need for 3 months to get to Mars, let alone stay there and get back, it's unrealistic. So they're just, like I said, the current plan is to utilize the resources that are already in space and to convert it into something, or take it for ourselves as something. But there's a lot of things involved with that. There's a lot of different departments with interacting with literal foreign objects from space, and how that will affect the astronauts and people here as well. So I'm gonna get into this. So this is the size of space. I'm gonna blow your mind again at how small we are. There's nothing like looking at space to put your mind into, to put you in perspective about life. So here we are, an astronaut, average person, whether you're short or tall, or just you're a human. So we're just gonna say a human, right? Then we have the Hubble Space Telescope, man-made object. There's only a few man-made objects on here I will point out. We do our best, but the galaxy is powerful. So we have a space shuttle, and then we have space station. Now you see we're already like barely visible compared to the space station. And then we have the Saturn V rocket, which I believe up to date is the largest thing that we have created to go to space, or space related. Of course, there's other things on Earth. If you took like the cumulative mass, it would be bigger, like the Great Wall of China. But in this sense, in terms of just pure height, this is the largest man-made object. So then we go to an asteroid, when things begin to quickly escalate, as you can no longer see a human compared to this asteroid. And this is an asteroid. This is not a planet. This is not a star. This is but a mere space rock. So this is Bennu. Then we have Deimos, one of the moons of Mars. Mind you, Mars is not a large planet, especially compared to the rest. So for one of its moons to be this large, you can't even begin to see where we are, So let's keep going. We have 243 Ida, another asteroid. Now I always get a little tensed when I look on the right side of this and I can't see anything, because it makes me think of how it's so large that it will not even begin to fit on my screen. So next, we have another asteroid, 4 Vesta. Ceres, a dwarf planet, another dwarf planet, and then Pluto. Now look, this is Pluto, a dwarf planet, something that we don't even consider to be big enough to be one of our actual planets. So on the upside, we know Earth is larger because we're considered a planet. But we can't see any man-made objects anymore. You can barely see some of the asteroids. The scale of these cosmic objects are just so large. And what blows my mind is I see it here on my screen, but then I think of like these things actually exist. This is not just a visual representation, even though it is what it is. But this is an extremely scaled out version of things that actually exist in reality. If I were to get a telescope and look out, they are up there in the sky. We have Europa, a moon of Jupiter, and then our moon. Not too much bigger than Europa. Io, a moon of Jupiter, Mercury, Titan, which is, I believe, the largest moon of Jupiter, and then Mars. So Mars is a good size, literal red planet. And then once again, we blow up and get a white dwarf star. Very small star, one of the smallest are white ones. But even compared to Mars is large. And at this point, the beginning asteroids we start off with probably are not even a pixel on the screen in comparison to what this is. And I also do definitely welcome, it should be in the chat down for everybody. I do welcome you to go to this website as well and just like take your time going through it. It's definitely a very mind-blowing experience, very grounding to say the least. When you think your life is crazy and your problems are bigger than reality, take a moment and go to this website and look at stuff. You're like, I think I can handle things. It's not too much smaller. It's a little, smaller. So we have Venus, rocky planet. I always think of Venus as purple for some reason. I think it's because of the dichotomy with the Greek and Roman gods. I always think it is purple, but it's definitely just a big rock. And so we have Earth, our home planet. You see everything there. It looks so quaint when you look at it this way. We see the map of the Earth every day. So it's hard for us, once again, living in a closed system on Earth, to really understand its scale in the universe. However, we're going to keep moving forward, and we're going to really see, now that we've reached where we are in the universe, let's see what everything else is compared to us. We have Kepler 22b, a Earth-like exoplanet. So once again, we have another planet out there that is Earth-like, has landmass, clouds, oceans, is bigger than us, which who knows really what that has effect on life forms being there. But it's something that does exist, something where we as humans could potentially live. And it's a lot larger. So, maybe in the future, as our population continues to exponentially, logarithmically almost grow, we could potentially move here and grow even more without the concerns of overpopulation. You have Neptune, our ice giant, Uranus, another ice giant, and then Saturn. I can tell, you can see off in the corner what's coming up soon. But we have Saturn, the gas giant, Jupiter, the gas giant, the largest planet in our solar system. Then the sun. It really blows my mind to think, like, how far do we really have to be from the sun to not be burnt? If it's this large and we're like way down there, way down there. I can only imagine how far, well, not only imagine, we can look it up, but we would have to be extremely far away from the sun in order to not get hot because of how small we are and how large it is. The heat radiating off of the sun is astronomical, literally astronomical. So then we have Sirius A, and then Pollux, a red giant. Our sun is just a yellow dwarf star, not a red giant, not a blue giant, not a white, but a red giant is Pollux. Our sun is minuscule in comparison. So to think of us as minuscule, but the sun is minuscule compared to other suns, mind blowing. And once again, it really gets you because thinking of how big, or the fact that these are realistic things. It's not sci-fi, but these are things that exist outside of Earth in reality. Sagittarius A, supermassive black hole. Arcturus, I'm not sure how to pronounce that. A red giant star, and another red giant, and then we get into the blues. Just like with fire, the hotter something is, the more like blue and white it gets on this color spectrum. So we're really hot right now. If this star was within our solar system probably actually wouldn't exist at all. So then we get into Pistol Star, our blue hypergiant, and another red supergiant star, Betelgeuse. So I'm sure people have heard of this before. In different contexts, the name of this star. I'm not sure which name came first. I feel like it would be this, just because a lot of astronomical names came from hundreds of years ago when the first astronomers really were getting heavy into science. But a lot of them you can tell from the name, like the more numerical the name is, the more likely it is that it's something that came about in the past few decades. So then we have this red supergiant. Once again, we can't see what's on the right, so it's probably large. Boom. M87 black hole, a supermassive black hole. You could tell, you could see the light bending around it, but look at how large this is. We're not even done. There's still more. We have this supermassive black hole, and then that supermassive black hole. These things that are out there, we think again of scale because of these objects that exist cannot exist remotely close to us. The larger an object is, the denser it is usually. And therefore, the larger its gravitational field, its magnetic forces. If things this large were even close to Earth by any modicum of space, we would be sucked in. So lucky for us, they are not. But they, like I said, they exist. They are things that are out there, and it really does give you like this sense of like where you are in the universe. So even larger than that, we have the Cat Side Nebula. Very pretty. I highly suggest going to NASA's website. I know they have plenty of pictures of the Cat Side Nebula. It's very pretty to look at. And we have a dark nebula. Personally, not as pretty, in my opinion. Ring Nebula, and one of my favorite nebulas, the Butterfly Nebula. It's really cool looking because of the shape of the butterfly. Speaking of butterfly effect, I'd suggest looking into that as well. And it does relate a lot to space and time when you look into the butterfly effect, but that may be a topic that we'll cover for another day because it starts very specific with how it got started. When we really start thinking about it conceptually, theoretically, it really branches off into a lot of other things. Crab Nebula, Kepler supernova, Titan supernova, and then a small galaxy, a dwarf galaxy. So we haven't even reached like the Milky Way yet. We are in the Milky Way, but we haven't even gotten to the size of it yet. The Tarantula Nebula, Barnard's Galaxy, the Fireworks Galaxy, and then us. So at this point, you can't see any black holes, you can't see Earth, you can't see us. We're but a blip in the universe. And that's not to say, because I think a lot of people, when they see stuff like this, they think that because we are so small in a universe, that it is insignificant. But you have to think, we are able to see these things. We have created technologies to see these things, to travel throughout space, to predict things that potentially can happen in space. Um, while we may not be making giant leaps and bounds to where we can go to the outer edges of the Milky Way, you have to start somewhere. And I think by keeping these type of things in mind, it allows you a certain sense of freedom to move around your life, but also to say, well, I can work within the confines that I have, but it gives me the ability to also build so that other people in the future or other people even now can expand those confines so we can travel farther, we can see farther, we can know more. So I think that's really a big thing about space and why I think it's so important is it's not just a cool thing to look at, even though it is really cool to look at. It's something that inspires, I think, discovery and expansion. Literally, the universe is about expansion. So we're Andromeda Galaxy. We have the supergiant elliptical galaxy, and then our local group, which I believe is like 50 to 100 galaxies, probably more. But galaxies, mind you, not planets, not stars, galaxies. These giant things that, these size beings, which now look small compared to the local galaxy, but are mind blowingly large compared to us. All of those within here. And then we have the Virgo supercluster, which is even larger than our local group. It's like saying what's on your block compared to what's in your city. And then we have this supercluster as well, a quasar group, which is starts to get to levels where it's like I can't comprehend what's going on. And lastly, the observable universe, which is current human capability of understanding of how large our universe is. We can't see further than this, partially because of the technology that we have, partially because, once again, the universe is constantly expanding. So, say we make something that can say like 300,000 light years away. By the time we create it, the universe has moved an additional 500,000 away. So, it's moving faster than we can catch up to. So, it does kind of make this sadness where it's like, will we ever be able to see everything? And it's not necessary, but it's a really cool thing to be able to know that we're working towards something that may or may not be possible. I think that is the beauty of science is in research and such is a lot of things that you're looking for um, in science. You don't know if they're possible. You don't know if you're right. You don't know if you're wrong. You don't know if it can be done, but you try anyway, and that's how you get the results that you're looking for. They may not be the results you're looking for, but that's how you move forward. That's how you make change. That's how you inspire other people to also move towards the future. I think now more than ever, especially this, I think that knowing where we are really, once again, gives that perception of we are humans here on this planet. We're possibly not going to go to the observable universe or to expand outside of the observable universe, but it gives us more of a sense of I can do here now what I can on Earth in my time and in my space. And over as time flows, I could potentially work on expanding my space, my circles of influence. But for now, this is where I am, and that's not a bad thing. It's just a starting point. So I that is really my rant, my thought explosion on space and time. Um, I don't know if your brain feels as blown as mine, but every time I look at it, I'm just like, I just need a moment to like stare out the window while it's raining, really just like let it sink in. Like, wow, I'm really a human existing in time, in space. It makes watching sci-fi movies a lot different after you understand. Like watching space movies changes after you look at things like this. Um, so that's what I have. I do want to once again point out this page because I think the creator of it did a great job when I found it. Um, he has like a share page where there's all these links. Some of them are real, some of them are not. For instance, like um, share with aliens. next time you get abducted by aliens, make sure to mention this page. I definitely will. I will give them a quick but somewhat digestible understanding of what space and time means to us as humans on this planet, and have them, tell me what they see time and space as from their perspective. And we can have a little powwow, learn from each other, build some cool spaceships. Um, so yeah, otherwise, I'm not gonna go too much into space and science, space and such anymore right now, but I will say before we end this show, I do want to point out again that we are having a contest for making snowmen. We'll be ending that at the end of this month, so make sure to go to the May School's Discord channel where you can find more details about that. Or once again, you can follow me on Instagram, and I have a few links on there about that as well. There will be prizes for best snowman, best landscape, best overall, and we really want to see your creations. Just encourage people to be more creative with coding and find a love for it beyond just sitting and monotonously typing on their computer. Yes, and then right after this as well, I want to point out we do have Tech Topical with Brian, so I would highly suggest you going over there. You can find out a lot more about where technology is in the present, how it affects our daily life, and how it's evolving in the future, and how the technology we have now will bring us to these points of this level of science that I'm speaking of, or go to different galaxies and planets and make them habitable. So that will start in about an hour from now, depending on an hour from now, regardless of what time zone you're in. So that'd be 4 p.m. Pacific. So I want to thank you all for coming with me today, taking the time out of your Saturday to learn some science, have your mind blown, question reality a little bit. Just remember, once again, time is linear, not in a circle. So now is always the best time to do something rather than waiting for the cycle to begin again. And with that, I will bid you all farewell, and I will see you next week. Bye-bye.